exposing the transmitters and receiver apertures, the smaller one being the transmitter, and you can see that the laser comes on starting the measurement and probes the atmosphere up to ranges of up to 20 kilometers, and it samples the atmosphere at 100 times per second in two wavelengths, one being invisible and the other being that brilliant green beam that was nicely shown in the animation. We can go on to the next slide. This is a picture, a camera picture of our instrument actually in operation on Mars. You can see that the cover's open and the instrument's taking data. This was a very proud moment for we Canadians, as Canada is so nicely displayed, and this is the meteorological station is our first set of instruments on Mars. So it was really a good day for us. Going on to the last slide, I'll give you a little example of some data that comes out of the LiDAR. This is really an evolution of the atmosphere directly above the LiDAR, and this is 15 minutes of data. It's a subset of the data we get back. And you're seeing data out to 5 kilometers, where the beginning of the measurement is at the left of the screen and the end is on the right. And the redder images are areas in the atmosphere where we have more dust scattering back more light into the LiDAR. So what's really interesting here is you can see there's actually an evolution of a dust feature given by the red at the lower right of the image as the instrument is measuring. And this kind of data we'll expect to see a lot more, and a lot more interesting features as we move forward with the instrument and get some measurements at different times of the sol as well. Okay. I'd like to pass on to Dave Spencer, our mission manager.
Thanks, Mike. Well, I'd like to describe a day in the life of surface operations. We're in Sol 5 now, and after 5 sols on the surface, the flight team is really starting to get into a rhythm. We synchronize our workday around Phoenix's workday on the surface of Mars. Just as Phoenix is finishing up its workday around 4 or 5 in the afternoon, the flight team is actually coming into the Science Operations Center here and gearing up for our night's worth of work to plan for the next day's activities on Mars. We start off with the kickoff meeting. We get the full team together in the big room and talk through the plans and objectives for the next day's activities. We also talk through any anomalies or issues that we need to work with, and this gets the team ready to go for the day. Then we wait for the downlink. Every afternoon, as Phoenix finishes its activities, it sends its day's worth of data from all the activities that it performed during the day up to an orbiter, either Odyssey or Mars Reconnaissance Orbiter, and that orbiter then sends the data back down to Earth. And for me, the best part of the day is when that data comes down. The science and engineering teams are in the work areas, huddled around their computers, and I'm generally out walking the halls kind of listening in terms of what's going on. Every once in a while I hear a little eruption of excitement as a waited for image, or if it's an engineer, a squiggly line comes down, and something that the team's been waiting for a long time, and that's really rewarding. Sometimes things get very quiet. The team will close the door if there's an issue that they've uncovered, and they get to work diagnosing it and come up with troubleshooting activities. So after the downlink period, we give the team a couple of hours to evaluate the data that they just received. We go into what we call a midpoint meeting, which is where we pull together the plans for the next day's activities on the surface. We start out with a template of activities that's been developed in the past. We're still in the characterization phase, so we've got very well laid out activities for each sol on the surface. But then we fold in the activities from the previous sols, including just recent information that we just got from the downlink. You've heard from Ray that we got this very intriguing image underneath the lander. We were able last night to schedule actually a duplicate image in Sol 5, which is going to be taken today on the surface, and that'll allow us to look for changes. If indeed this is ground ice, we'll be able to see any changes if indeed that ice is evolving on the surface. Last night we responded to the TIGA anomaly by pulling out scheduled TIGA activities from the plan, and that will give the TIGA team a day's worth of work to come up with a troubleshooting path. We didn't want them to be bothered with analyzing and validating commands during the planning sol last night, so we effectively gave them the day off to work the anomaly. So once we have the plan established, then we go into an implementation phase, which starts late at night and goes through the wee hours of the morning. During this time period, the team's building commands, validating those sequences. We go through a very rigorous process of walking through these commands line by line to make sure that everything's going to work as expected when these commands are actually sent to the spacecraft. It's really a race against the clock because Phoenix is going to wake up on time every morning, and we need to get these commands up to an orbiter, forwarded on to the lander, so that when it wakes up, it gets its instructions for the day. And so far, we've been right on schedule every day. So for this day, which is Sol 5 on the surface, the centerpiece activity is actually using the robotic arm and the robotic arm camera to look underneath the lander, check out each of the lander legs and the foot pads to ensure that the lander is indeed stable. We need to do this so that downstream, when we want to interact with the robotic arm on the soil, that we know that the lander has a stable platform and provides that for the robotic arm activities. We're also taking more atmospheric measurements. We're taking some very precise images of a future dig site, which is called Humpty Dumpty. And all this data was going to be forwarded on to our next planning sols activities. And Leslie Tampery, our project scientist, is going to talk about our downstream activities.
Thank you. So yes, I'd like to tell you a little bit more about our strategic planning and what we have in the future coming up. Dave gave a very good description of the tactical process, and I'll tell you a little bit more about the strategic process and how that works. As you know, the first part of the mission is dedicated to checking out the instruments and doing our first touch of the soil and testing that soil and doing our little dig and dump. That will tell us something about the soil characteristics and properties, if it's loose consolidated or unconsolidated material, or if it's more hard and consolidated, and that will allow us to understand better how to dig in the future. So all of these activities are very important to us. In the very near term, in addition to what Dave mentioned, we're taking some imaging data to try to understand some of these potential test dig and dump sites so that we can check out how the surface materials look. And let's see. And we also are going to, of course, take more data of this feature under the spacecraft that Ray talked about that may be a rock or may be ice, as was mentioned as well. So we have our strategic plan as well. So after the day's activities, when the commanding process goes off and the line-by-line checking process is going on, as Dave mentioned, the scientists go off and start strategic planning. So we're looking at refining the plan for the following sol, not the one we've just planned, but the following one, and then even sols 1 week to 2 weeks out ahead of us. So we have a strategic plan laid out now, out through about sol 22. And this plan is, we have a nominal plan, but obviously this plan has pathways because things will happen. We're designed to be discovery responsive. Our tactical and strategic processes will be able to be flexible and change as need be. So every sol, when we get the day's data, we not only evaluate it and say, do we want to execute the plan that we had laid out for today as planned, or do we need to make modifications? But we feed that information forward into the strategic process to modify downstream as well. So the upcoming activities are the test of the robotic arm, or the test, touch and dig and dump of the soil, and also we'll be looking forward to actually getting our first soil sample. And we have a digging process that will allow us to, and sampling process that will allow us to